Zwagala, Aibo. Shop, the future's calling. Maths and mind colliding. Daily dose of power. AI's here. Siaya. Kubeka, let's learn the new way. Siahamba Pezul. Daily dose of power. AI's here. Siaya. Kubeka, let's learn the new way. Siahamba Pezul.
Hi guys, welcome to another lesson of the Daily Dose of Mathematics. Today we're continuing with the bouncing ball. We're doing 3.2.2. Sia, what is our question for today?
Show that the series converges.
So we're supposed to show that the series converges. We took this one from the June 2026 Limpopo question paper. So now guys, we're supposed to know what is the condition for convergence. For us to be able to do this question, we are supposed to remember what do they mean when they say a series converges. Now the only way a series can converge is if R is greater than -1, but R is less than 1. So that's what we should look for. We're going to look for the value of R, and then it should be a value that is between -1 and 1. 1 and -1 not included. So from what we got yesterday, we got our pattern. Now let's go and show them how did we get our pattern. We can just do a quick preview there so that we remind each other what was the pattern. Okay, what was our pattern that we got yesterday? What was the initial?
It was 30.
So we start with the initial drop of the ball is 30.
24.
Then we had 24.
19,2.
Plus 19,2. Yeah, by the way, it's a series. I'm using plus instead of dots. So it's 30 plus 24 plus 19,2 ... So this is a series. Now, we're supposed to determine R because R is the one who's going to tell us whether this thing converges or not converges. So we're going to say R. How do you get R? Now we get R by saying T2 divided by T1. And then we check that. What is our R? Our T2, by the way. What is our T2 here?
24.
So we say it's 24 divided by our term number 1. What is term number 1?
8.
It's 8. Okay. Now, if you were to type this in your calculator, what do you get? We should get, it's 30 divided by 24. You can check it.
24.
Divide by, yeah.
Divided by 30.
Yeah.
It's 4
over 5. Okay, 4 over 5. We want it as a decimal so that we'll be able to put it on our number line.
0,5.
0,8. Okay, 0,8. Okay. Now, remember, if we put this in a number line, we're going to write it in a small number line here and say our value is between -1 and 1. And then here, between -1 and 1, you can have 0. Now, we're going to check 0,8. Does it fall in between -1 and 1? Where do you find it?
Positive side.
On the positive side, yeah. So you can just tick here and say, yeah, it falls somewhere here and just show them it does fall here. So therefore, we're going to tell them that -1 is greater than, so we're going to tell them -1 is greater than 0,8, but R is less than 1. So our 0,8 is less than 1. Part is greater than -1. Yeah?
Yeah.
Therefore, we're going to write therefore, 3 dots. Therefore, our series converges. It converges. Okay, guys, remember we're going to put this in our senior marker. Remember, as we prepare for examination, we want to know how are they marking at the marking center. So while we do that, we're going to play our song. Let's go and play our songs here.
What is left? That's a total you made. 0.8. And if they give you terms and you need to find the rule, term 2 over term 1, that's the ultimate tool. Geometric means we multiply, we don't subtract the size. Divide the current by the previous, open up your eyes. Whether fractions or percentages, we control the rate. What do you keep? Obey! We are born now. T2 divide by T1, we taking it far. Don't multiply the loss, no, that's a mistake. Multiply by what is left, that's a total you made. what you keep. T2 over T1, never the loss. Always the ratio, lock it in. Lock it in, shop.
Okay, guys, let's listen to our
CAPS marking audit. Total marks awarded, 1/2. 1. Marking breakdown. Step. Working shown. Mark allocation. Justification. Common ratio calculation R equals, frac, T_2, T_1, equals, frac, 24, 30.08, checkmark A. Accurate identification of the numerical ratio value 0, 8. Convergence condition and conclusion. -1 less than 0, 8 less than 1. Therefore our series converges. 0. Mark lost. The introduction of invalid mathematical notation within the calculation line invalidates the full formal presentation of the proof. 2. Corrective feedback. Look closely at your second line in image_EBA4C6 linked to .png. You replace the equals sign between frac 24, 30, and frac 4, 5, with a colon. In formal mathematics, a colon denotes a ratio or a division operation, not equivalence. By writing a colon here, you are stating that frac 24, 30 is being divided by or compared as a ratio to frac 4, 5, which completely breaks down the logical chain of equality. Socratic question. If an examiner reads that line strictly as written, it simplifies arithmetic-wise to frac 24, 30, div. frac 4, 5, which equals 1. How can we fix this notation to ensure every single expression across that line remains perfectly equivalent? 3. CAPS and formal notation compliance. Terminology. Therefore our series converges, is perfectly acceptable. Notation. This is where the mark was lost. Chaining steps together using incorrect operational symbols, like colons instead of equals signs, is treated strictly by National Senior Certificate, NSC, external markers. Every item in a continued equation line must be exactly equal to the item preceding it. 4. Coach's summary. What you did well. Adding the asterisk, on your number line graph precisely where 0, 8 sits is a fantastic visual representation. It explicitly anchors your theoretical value onto the valid visual domain. Area for improvement. Never use punctuation marks or informal shorthand, like colons or arrows, inside a formal algebraic equation chain. Keep it strictly to standard equals signs, equals. If a step requires a transition or simplification that doesn't fit a clean equality chain, drop down to a brand new line.
See a bonga for pulling through the lesson. Hope you caught that daily dose of magic. Like the video and leave us your thoughts. Your comment counts, tell us what you need. Your comment counts, tell us what you need. Find us on TikTok and Facebook. The daily dose of mathematics is the handle. Hit our WhatsApp for the daily prompts. Get more info on 0664 682 9994. 064 682 9994. Hamba kahle.